This is chapter 12.1, right triangle trigonometry. And right triangle trigonometry uses ideas from the Pythagorean theorem, where you have a right triangle with the sides A, B, and C being the hypotenuse because it's directly across from the right angle. A and B are both legs. And from that, we remember the formula for the Pythagorean theorem, which is a squared plus b squared equals c squared. We can use those ideas in trigonometric functions. So we have another right triangle, as you can see to the right there. And the hypotenuse is still directly across from the right angle, so it's called the hypotenuse and is abbreviated HYP. Now, the little acute angle is called theta. Okay, so the theta is the acute angle of this right triangle, or it's the acute angle of any triangle. So there I went ahead and wrote the word theta. Now, directly, so here's my theta right here. And if my theta were an eye and I were looking directly across from that, that's going to be my opposite side. And so my opposite side is shown as OPP. And then that leaves just the last side over here, right here, and that's your adjacent side. So I always determine what my opposite side is first. It's easy to determine hypotenuse, easy to determine opposite, and then whatever's left is adjacent. And that's abbreviated ADJ. So the memory device that you use for ratios, trigonometric ratios, and the only three ratios we're going to do are sine, cosine, and tangent. So sine theta, cosine theta, and tangent theta. And the memory device is SO, CA, TOA. And it doesn't really make any sense, SO, CA, TOA, but it sticks in your head. So SO, S-O-H, stands for sine equals opposite over hypotenuse. CA, C-A-H, stands for cosine theta equals adjacent over hypotenuse. And TOA stands for tangent theta equals opposite over adjacent. Okay, so in this picture, on number 1, which is from checkpoint exercise, page 646, before we go on, there's going to be 2 assignments associated with chapter 12.1, right triangle trigonometry. First assignment will be page 648, 1, 3, 4 through 7, 8, and on page 649, 35. And then you'll have pages 648 to 649, 13 through 33 odd. And this will give you some experience with the right triangle trigonometric functions. Okay, we have this triangle in number 1. And it's got a hypotenuse of 25. It's got an opposite side of 7. 7 is directly across from theta. If theta were an eye, you would be looking at the 7. And then the 24 is what's left, and that's adjacent. So for sine, so S-O-H, sine equals opposite over hypotenuse, 7 over 25. It can't be simplified any further. For cosine, CA, cosine equals adjacent over hypotenuse, 24 over 25. Can't be simplified. And TOA, tangent theta equals 7, which is the opposite, over the adjacent 24, which cannot be simplified. Now, I'm going to ask you to copy down this table. It's in your book, but make sure you have this table copied down. These are for special right triangles. The 2 special right triangles are 30, 60, 90 right triangles, and the other one is 45, 45, 90 right triangle. This table has all the trigonometric functions listed in it. And it can be used to quickly calculate what the sine, cosine, or tangent is of something if it is one of these special right triangles, either a 30, 60, 90 or a 45, 45, 90. We're going to use that table on the next problem. All right, this is page 646, example 2. And I've drawn the picture right here. I'm going to go around it with that eraser. And what you're going to do is you're going to be finding that missing side length. You're going to find the x, but you have to figure out which of the trigonometric functions you're going to use. In this case, you have your hypotenuse. The 8 is your hypotenuse, and you can see that because it's directly across from the right angle. So you've got your hypotenuse, which means right now you know that you're using either, you're going to use your cosine or you're going to use your sine, okay, because those are the 2 that have hypotenuse in them. And then this other thing that you know is that this is the theta. This 30 degrees is your theta. So your theta equals 30 degrees. If I went straight across, like an eyeball looking straight across, that would be my opposite, but I don't have an opposite, I have an adjacent. So this is adjacent. So right now, you know you've got to use cosine. So we're going to go cosine and 30 degrees. Now you can do this on the calculator, but we're going to actually use the table that's in your notes, and also it's on your page 646, so you can look either place, whatever's easier for you. And cosine 30 degrees equals, we know we're going to do cosine, so it's cosine equals adjacent over hypotenuse. We're going to start by just writing that down. And then we're going to go into the table and we're going to pull out whatever cosine 30 degrees is. So you can go ahead and look right now. I'm going to pop back up to the table. And then we've got cosine 30 degrees is the square root of 3 over 2. So I'm going to substitute that. So cosine 30 degrees is the square root of 3 over 2. We know that adjacent is x, so equals adjacent. And we know that hypotenuse is 8. So now you have a proportion, and whenever you have a proportion, you can use cross products. So I'm going to multiply 2 times x, 2x, and I'm going to multiply 8 times the square root of 3. And then I need to isolate x because I'm trying to figure out what x is right here. So I'm going to divide both sides using the division property of equality, both sides by 2. And x is going to equal, you've got, let's change the color here, ability to cancel here. That's 8, that's 2. Both are divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4, so you're left with 4 times the square root of 3. You could also get that same amount, but you wouldn't get it with a radical symbol. But if you put in, if you did the math algebraically, which we will do in later chapters, you would be able to put that into the calculator and figure out your x value, your side length. Okay, let's go ahead and have you try page on the checkpoint activity. This is 646. You're going to do this, draw this picture. So you've got your x at the top, your right angle is right there, your 60 degrees is your theta, and your 4. This is number 2. So this is number 2 from the checkpoint activities. And we're going to go ahead and use the table again on this one. You could also do it on the calculator using the keys, the cosine, sine, and tangent keys, but we're going to go ahead and use the table. Okay, so getting that drawn, go ahead and try this on your own. See if you can figure out which of those trigonometric functions you're going to use, sine, cosine, or tangent, and then solve it, and then turn the recording back on. Okay, let's see how you did. Okay, looking directly across from the right angle, we know nothing about the hypotenuse. So you should automatically know if you don't have a hypotenuse, then you're not going to have sine and cosine. So that means we're going to be needing tangent. Now we need to identify, this is our theta, the 60 degrees. Directly opposite that is x. So we know we're doing tangent of 60 degrees, and we know tangent is TOA. So that's our little memory device, TOA, which means opposite over adjacent. Now we're going to use the table, we're going to substitute. Let's just go back, it's tangent 60 degrees. So going back to the table, there's tangent 60 degrees is the square root of 3. So we're going to put the square root of 3 in place of tangent 60 degrees. Now you can use the calculator and use the tangent key, that works too. Opposite is x, adjacent is 4. Now you might not be seeing the cross product here, but if I put the square root of 3 over 1, let's change the color. It doesn't change anything. Square root of 3, square root of 3 over 1 are the same thing. So now I can use cross product because it is a proportion. So that will be 1 times x, which is just x. And then 4 times the square root of 3. So 4 times the square root of 3. That can't be simplified any further. And so that is your answer. X equals 4 times the square root of 3. Now these were solved using the table that we saw right here. You can solve and find side lengths using your calculator. the table only works, let's go back there one more time. The table only works if you have a special triangle, either a 45-45, 90, or 60-30, 90. But as you know, there are right triangles that are not special right triangles, so you have to use your calculator for that. Okay, now I'd like you again to try checkpoint, checkpoint activity number 3 on page 646. This is a 45 degree. It's also a special triangle, so again, you're going to use your table. So see if you can figure out which trigonometric function you're going to use, sine, cosine, or tangent. Go ahead and try to solve this. As soon as you're done, go ahead and turn the recording back on and see how you did. Okay, so as I looked at the picture, here's my right angle. I had the amount right directly across from the right angle, which means that 9 is the hypotenuse. It's helpful to label it right on the picture. I also knew that this 45 degrees was my theta, so it's kind of hard to fit it in there, so I put it right there. Theta was straight across. That means that was opposite. Well, there's nothing there, so opposite isn't what we needed. We needed adjacent. So this is again a cosine problem. Adjacent over hypotenuse, cosine equals adjacent over hypotenuse. That's what you're going to use. So cosine 45 degrees, you're just substituting in values, equals adjacent is x over 9, which is hypotenuse. You substitute. Now, cosine 45 is one of those special triangles. Let's go back up in our graph so you can see it. And it was 45 going over to cosine. Cosine 45 degrees is square root of 2 over 2. There, you can see it right there. All we did was substitute it in. Square root of 2 over 2 equals x over 9. We just brought that down. Using cross products, we would have had 2 times x, which is 2x. 9 times the square root of 2, which is 9 square root of 2. You're going to divide, I put them together in one more step instead of just leaving the time sign. You're going to divide both sides by 2. 2x divided by 2 is x. 9 times the square root of 2 divided by 2 is as simplified as it can get, because 9 over 2 cannot be simplified any further. So it's 9. X equals 9 square root of 2 over 2. Yes, you could get this on your calculator. You get an approximate decimal amount, but this is how you use the table. Again, you have another opportunity to practice on page 646, number 4 from the checkpoint activities. Another opportunity to practice with the tables, because this again is a 30-degree right triangle, so it makes it one of the special triangles. And then we're going to move into, after that, so I want you to practice on that, turn the recording back on, and then we're going to move into when they are not special triangles. Okay, number 4, you found the sign. You can go through the steps, check it against the table, but given the short amount of time I have left on the recording, I'm going to have to move on, so you can look through the steps. Okay, let's take a look at number 5. This is going to require a calculator because you've got a theta that is 25 degrees. So go ahead and take a minute, draw this picture, write that you need to use a calculator, and please note that it must be in degree mode. Okay, as you look at the picture, you can see that theta, directly across from theta is x, which is your opposite. You can also see you have no hypotenuse. There's nothing directly across from the right angle. And then 10 has to be your adjacent. So it's TOA. Tangent equals opposite over adjacent. So tangent 25 degrees equals opposite over adjacent. Tangent 25 degrees equals x over 10. In order to get x isolated, I need to multiply by 10 on both sides, because the opposite of division is multiplication. And I'm going to end up with this canceling and becoming 1. And I'm going to plug in 10 times and then hit my tangent key 25 degrees, and I will come up with my answer. So x is going to equal, I actually should have said x is approximately 4.7, so that's the length of that side. Okay, this is example 3b. The previous one was 3a from page 647. Go ahead and draw the figure. Figure out which of the trigonometric functions you're using, sine, cosine, or tangent. Show all your work. I am going to give you an additional way of doing this, but go ahead and try it on your own first. I'm going to show you how to solve it proportionally. And then turn on the recording and check it out. Okay, you can see you have a hypotenuse. X is directly across from the right angle. You can also see that directly across from theta, 63 degrees, is the opposite, but there's nothing there. So that means that 3 has to be the adjacent. So you're going to use cosine equals adjacent over hypotenuse. So cosine 63 degrees equals 3 over x. You may have gotten a little stumped here, so this is where I'm going to help you. If you put a 1 underneath cosine 63 degrees, you simply would go x times 63, or x times cosine 63 degrees equals 1 times 3, which is 3. So we made a proportion and used cross products and came out with x is approximately 6.6.